Hello, this is the part 6 of the video series on solving triangles. So this will be the last part of the series, and it's going to be on bearing and distances. Now, bearing is simply a way of representing the direction of a point relative to another point. For example, if I'm here, let's say I'm here at this point, I call this point A. So, and I want to locate the direction of another point B relative to point A. So I want to know where this point B is from this point A. So I can use bearing to represent that direction. So if I give the bearing of this point B from point A, then I know exactly where this point A is if I'm just considering the direction. So like that. So there are two ways of representing bearings. The first way is the true bearing method. So there are two methods. The first one is a true bearing, where the direction is represented or direction is measured. Direction is measured in a clockwise manner from the north line. So that's the first way. So the bearing is usually represented as a 3-digit number. For example, let's say 0, 3, 0 degrees. So if this is a bearing of a point from another point, then we can represent this by measuring angle 30 degrees from the north line. So what do I mean by that? So let's say this is my starting point. I'm here, and I want to measure the bearing of another point. Let's say this point B, and the bearing of this one, this is point A. The bearing of B from A is 30 degrees. So I have to start from the north line. Then if you write the cardinal, this is north, this is east, this is south, and this is west. So if I'm using the first method, the true bearing one, which is given this way, I have to measure 30 degrees from the north. So if I draw a line, 30 degrees, and that means my point P will be located let's say around here. Now I'm not considering the distance, I'm only considering the direction. So that's how to represent that. So 0, 3, 0, basically 30 degrees from the north. So you in a clockwise manner. So let's say we want to locate 0, okay, let me that one. Let's say we want to locate 150 degrees. So how do you do that? So you start from the north, always from the north, and you go in a clockwise manner. So this is 90 degrees. Then, 150 degrees should be between 90 and 180. This is 180 degrees. The angle on a straight line. So that means 150 should be somewhere here. So this is 150 degrees. Okay. So that's how to locate that bearing. So let's say I want to locate 270 degrees. So that should be here, because this is 90, 180, and 270. So 270 is straightly here, this line. So if I want to locate, let's see, so if I want to locate 310 degrees, for example, it's going to be this is 90, 180, 270, and 310. Should be here. So 310. So what is important here is that you measure the angle from the north in a clockwise manner. Let me put arrows to show that. So we measure the angle from the north in a clockwise manner. So the second method will be using the conventional bearing. Here, direction is measured east or west of the north-south line. South line. So what do I mean? So if I want to measure this bearing using this method, so the bearing is usually given in this form. Maybe you have north 30 degrees east, you have south 45 degrees west, or you have north 60 degrees west, something like that. So we use the north-south line. So if I want to locate that, north 30 degrees east, so I will draw the cardinals. It's important you know how to represent the cardinals correctly. Then, because this northeast, that means my angle will be between the north and the east, but this time around, but the angle will be measured either to the north or to the south, depending on whether you have northeast or north and something else or south and something else. Now, because I have north and east, that means my angle has to be between north and east, but the angle must be measured from the north. So it's going to be like that, 30 degrees. So this will be southwest. So this is north, this is east, this is south, and this is west. So southwest is here, this is direction, but the angle has to be measured from the south. So the angle is either measured from the south or from the north, depending on what you have. So this is 45 degrees there. So it's measured to the north, to the south this time, but this one is measured to the north. So this one will be, this is north, this is east, this is south, and this is west. And 60 degrees north, 60 degrees west will be this way. And to go that way, but the angle has to go to the north, 60 degrees. Okay, so that's the second method. So depending on which one you have, then you draw it accordingly. Now let's look at some examples. So the first example we have here is that we have 3 villages, A, B, and C. And B is 6.4 kilometers due east of A, and C is 3.8 kilometers from A on a bearing of 210 degrees. And we have to calculate the bearing of B from C, give the answer correct to the nearest degrees. So how do we do this? Now we have to first draw the diagram, the triangle, so we eventually get a triangle. Now let's locate the villages. B is 6.4 kilometers due east of A. So if I draw A, let's say my point A is here. B is 6.4 kilometers due east. So east, this is east, if you remember. So I will just go, because it's saying due east, that means I will just continue on the east, in the east direction, 6.4 kilometers. So that means B should be somewhere here. And C is 3.8 kilometers from A on a bearing of 210. So 3.8 kilometers from A. This is very important. So that means we are locating the bearing on A. So we are doing it at point A. So because it's saying from A. And you come to A and you locate this bearing, 210. Remember the way you do it, you have to start from the north and you measure this angle in a clockwise direction. So this is 90, this is 180, and this is 270, but it's 210. It has to be somewhere here. Okay. So, and what is the distance? These are not drawn to scale. So I think that's too long. Let me make it a little bit shorter. So 3.8 kilometers on a bearing of 210. So everything is 210 degrees. So if I connect, this is C, if I connect point C to B, I have that triangle. Now, how do I solve this? I need to calculate some angle before I can solve it using either sine rule or cosine rule, because the triangle we have is not right angle triangle. Clearly, we can see that. Now, this is from here to here is 210, and we know that from here to here is 90 degrees. So we know that this angle would definitely going to be 210 minus, that's angle A, is going to be 210 minus 90 degrees. And that will give you 10 minus 90, 120 degrees. So we know that this angle is 120 degrees. Now we are looking for the bearing of B from C. The bearing of B from C, saying from C. So what I need to do is to get this angle because I want to measure bearing of B from C. So my angle has to be at C. Now, if I want to get that angle, I have the side that is facing this angle I'm looking for, but I don't have this side. So what do I do? I need to first calculate this side BC. So if I calculate this side BC using cosine rule, because I know the angle that is facing that side, then I can use that to calculate this angle. So now let's do that. Because we cannot use sine rule here because we don't have the angle that is facing this. Yeah. So let's use cosine rule. BC squared will be equal to AC squared plus AB squared plus, okay, let me use small letters. So this will be small a, and this will be small b, and this will be small c. So a squared will be b squared plus c squared minus 2bc cos a. So a squared will be 3.8 squared plus 6.4 squared minus 2 times 3.8 times 6.4 cos 120. So a squared will be 3.8 squared plus 6.4 squared. So this will give us 55.4. I just want to do that part first. Minus 2 times 3.8 times 6.4. So that will give you 48.64 times cos 120 degrees, that should be cos 60, because it's 180 minus 120. So cos 60 should be minus 0.5. So multiply by 48.64. So a squared will be 55.4 plus 24.32. So 25.32, 55.4. So a squared will be 79.72. So a will be square root of 79.72. And a will be 8.93 kilometers. So now we have a as 8.93 kilometers. So we can then use that. We can then use sine rule to figure out this angle C. So if I use sine rule to get angle C, then I'll have A over sine A equals C over sine C. So what's A? That's 8.93 over sine 120 degrees equals C as 6.4 over sine C I'm looking for. You cross multiply, you have 8.93 sine C equals 6.4 sine 120 degrees. So sine C will be 6.4 sine 120 degrees divided by 8.93. So 6.4 sine 120 and divided by 8.93. That's 0.62. Sine C 0.62. So C will be sine inverse of 0.62. C will be shift sine of the answer, and that gives me 38.4 approximately degrees. So now I know this angle as 38.4. So I can easily calculate the bearing of B from C. So when we want to calculate the bearing of B from C, so what I have to do is to start from the north at point C and keep moving until I get to the line that connects B and C. Yeah, this is the angle I'm looking for. The bearing of B from C, that means when I connect B and C, and I start from the north of C, because it's saying from C, I'll keep going in a clockwise manner until I hit the line that connects C and B. So that is the angle here. How do I get that? I know this angle as 38.4. So which means I just need this small part here. How do I get that small part? I think I can get that from here. So this is 120. So this from here to here, it should be 90 degrees, which means from here to here will be 30 degrees. So if that's 30, that will be alternate to this angle here, 30 degrees. So which means the bearing will be 30 plus 38.4. So the bearing of B from C equals 30 degrees plus 38.4 degrees. And that gives us 68.4 degrees. Okay, so that's the solution to that. I hope that's clear enough. So let's look at another example. Now from mass Q, mass Q is on a bearing of 100 degrees from mass P and is 40 kilometers away. So the bearing of mass R from mass Q is 150 degrees. So mass P and Q are 66 kilometers apart. So the question is, Find, okay, the first question is how far is mass Q from R? And the second question is, what is the bearing of mass P from mass R? So how do we do this? Now let's locate the three masts. The first part of the question says Q is on a bearing of 100 degrees from P. So I have to start from P. So let's say my point P is here. This P. And we are told that Q is on a bearing of 100 degrees from it. So 90, I have to always start from the north and go in a clockwise manner. This is 90 and 100 should be like that. So this is 100 degrees. Remember, these are not drawn to scale. So, and it's 40 kilometers away. So let's say this is 40 kilometers. This is point Q. So the bearing of mass R from Q, there's another mass R that is on a bearing of 150 degrees from Q. So from Q, I will start at Q and I will measure bearing of 150 degrees. So this will be 90, then 150 should be somewhere there. So this should be 150 degrees. Now I can then connect. So this is, so we're told that P and R are 66 kilometers apart. So from here to here is 66 kilometers. Now I have the triangle. It's not a perfect one. How do I get the angle that I need? So from here, I know that this is 100. So, and this is 90 degrees from here to here. So this has to be 10 degrees. So, and that 10 degrees will be alternate to this angle here, 10 degrees. Cool. Now, and I know that this angle here, this is 90, that's clear enough. And this, I need this part of the angle, this part here to fully get the angle here. Now, how do I get this part? I know from here to here is 150. So which means this part will be 30 because everything on this straight line has to be 180. So now I have three parts of the angle, 10, 90, and 30. So if I add them together, so I will have 130 degrees. So that is the angle there. Now I know that angle, I know the side. So I know this side. So how do I get this angle that is facing that side? You know, this angle is the angle that is facing this side. So this is R. So this will be small r, this will be small q, and this will be small p. Okay. So now I know this angle, I can calculate what do I need to get first. How far is mass q from R? So I want to get P, this side P. This. No, I need to get the angle P before I can do that. So how do I get angle P? I can use this side angle. So I need to get this angle first because I know side R. So if I use sine rule, using sine rule, R, okay, Q over sine Q will be equal to R over sine R. So what is Q? 66 over sine 130 degrees will be equal to R 40 over sine R. So by cross multiply, then I'll have 66 sine R equals 40 sine 130 degrees. So sine R will be 40 sine 130 degrees over 66. So if I press my calculator, then I'll have 40 sine 130, then divided by 66. So shift. So that will give me R sine R should be 0.464. Then R will be sine inverse of 0.464, and R will be shift sine of 0.464, 27.6. So that is this angle, 27.6. So I can use that to figure out this angle because everything was add up to 180 degrees. So that angle there, angle P must be equal to 180 minus angle R minus angle Q. Okay, so I need to go to the next page. So angle P will be equal to 180 minus R 27.6, 27.6, and 30. So P will be 180 minus 27.6 minus 130. That's 22.4 degrees. Now I know P. This angle as 22.4. Then I can use that to get the distance P. So if I use sine rule, P over sine P will be equal to Q over sine Q. P, using sine rule again, P over sine P, the Q over sine Q. So P is what I'm looking for over sine 22.4 will be equal to, what is Q? Q is 66. So 66 divided by sine 130 degrees. So if I cross multiply, P sine 130 degrees will be equal to 66 sine 22.4 degrees. So P will be 66 sine 22.4 degrees divided by sine 130 degrees. So P will be 66 sine 22.4, then divided by sine 130 degrees. So that's 32.8. So 32.8 kilometers is P. Okay, that's the distance between Q and R. Then the second question is, what is the bearing of P from R? So what is the bearing of P from R? From R, we are here. So we want to find this angle. So I will start from R, saying from R, then I'll go in a clockwise manner until I hit the line that connects P and R. So this is the angle I want to find. So now I can see clearly that this is 270 plus this angle here. So how do I get this angle here? So this angle should be alternate to this angle. So then this angle here will be 10 plus 22.4. You can see 10 plus 22.4, that's 32.4. 32.4. Then the bearing will be 270 plus 32.4. 270 plus 32.4. The bearing of P from R is 270 plus 32.4, and that gives us 302.4 degrees. Okay, so we stop there, and I'll see you in the next video. Bye bye.